All right, so today we are going to solve some trig equations. The reason why this section is called basic trig equations is that there are more complicated equations. Okay, we are going to start slowly with some of these, and when you are solving these, you need to know the difference between an identity and an equation. So if it's an identity, okay, identities are true for all values of theta. I'm going to grab a new marker for that. So identities are true for all values of theta. And then equations are only going to be true for certain values, not all of them. Okay, so today we're solving equations, so we're going to find certain values of theta that will satisfy the equation. Okay, if you were to plug a value into theta for any of those identities that we are proving, it would work for all values. Okay, so for example 1, you are going to solve the equation. So we are going to find the solution in the interval 0 to 2 pi. Okay, there are going to be some of these where we're using our calculator. So when that happens, you want to make sure that you are in radian mode. When you reset your calculator, it automatically goes back to radian mode. And there are going to be some of these where you're going to use a calculator, others where you are not. So if it is something that you can solve by using those special points on the unit circle, those exact values on the unit circle, we are going to do that. Okay, if it is not an exact value on the unit circle, then we are going to use our calculator to solve. Okay, so when you're solving the equation, we are going to find the solution in this interval, and then we are going to find all of the solutions. And we want to make sure we are in radian mode. Okay, so for your cosine of theta, it says it equals negative root 2 over 2. Remember that 1 period for cosine is 2 pi. I want you to go ahead right now and I want you to circle the 2 places on your unit circle where the cosine is negative root 2 over 2. So remember the cosine is going to mean your x coordinate. So where is your x coordinate? Negative root 2 over 2. So go ahead and circle those on your unit circle. Okay, we're in radian mode, so I want you to circle the radian values. All right, so Nina, give me one that you circled. Yep, so 3 pi over 4 is one place where your x is a negative root 2 over 2. And then here's what was the other one? 5 pi over 4. Yep, 5 pi over 4. Okay, so those are the only 2 places in the interval 0 to 2 pi. So your solutions are going to be 3 pi over 4 and 5 pi over 4. Now, when it says find all the solutions, what that means is we are going to write an equation because all of the solutions, there's going to be an infinite amount. Anytime you hit this point, you're going to have a cosine of negative root 2 over 2. So if you were to go around the circle again, you would be adding what value to 3 pi over 4? Yeah. And so what we're going to use as our equation is 2 pi k. In this case, this means where k is any integer. You don't have to write that every time. We're just going to write it down in our notes. Okay, so if k is any integer, that means you can go around the circle once, twice, as many times as you like in the positive direction, but integers also include negatives, so you should, you can also go around the circle counterclockwise, okay, or clockwise and counterclockwise in order to hit all of those values. And then the same thing with 5 pi over 4, so it'll be 5 pi over 4 plus 2 pi k. So if you're finding a solution in the interval, you only need those solutions in radians. If you are finding all solutions, okay, then you are going to need an equation where k is an integer. All right, and then for part B, it says the tangent of theta equals 5. So the first thing we want to do is see if it's on the unit circle. With our tangent values, okay, we know our tangent values in quadrant 1. We have root 3 over 3, 1, root 3. Here, remember you do y divided by x. So this would be an undefined value. This would be 0. So the tangent being 5 is not an exact place on the unit circle. So when that happens, so it's not an exact value on the unit circle. Okay, so when that happens, we wrote what to do down here. Okay, you're going to use the inverse function on your calculator to find the value for theta if the equation is not equal to an exact value on the unit circle. Give me 1 second. And you do have to make sure that you are in radian mode. Okay, and then we are actually going around to 2 decimal places and not 3. Okay, and then question. Oh, yes. Okay, and then 1 period for the tangent is going to be pi. Okay, and then when you are doing these for part B, what I want you to write out is what you are doing on your calculator. So you're going to be doing the tangent inverse of 5. Again, check your mode. Okay, and then if you need a calculator, I have some more scientific ones that I can help you with. If you just need that, and then we write down what the theta is. Okay, so some of your calculators are going to display right on the screen whether you're in radians or degrees. Okay, so mine does say radian up here. You can also just go to your mode and double check. Alright, and then we're going to round to the nearest 100. Okay, so I got theta is equal to 1.37. Okay, that is one of your values. Okay, so in step one of your answers is 1.37. There is going to be another one. So we're going to talk about how we know that based on the patterns of the unit circle. Okay, so when you're looking at your tangent values, we wrote down the tangent values for quadrant 1. Okay, and then if we write down the values for quadrant 3, your tangent values, this is going to be root 3, this is going to be 1, this is going to be root 3 over 3. Okay, you can continue that pattern around the circle. So this would be negative root 3 over 3. This would be negative 1, negative root 3. Okay, and then here you have negative root 3, negative 1, negative root 3 over 3. So take a moment to just notice these relationships. 1 and 1, root 3 and root 3. So they have the same value if they're located where? Yeah, directly across the circle. So how many radians are in between those if it's directly across? 1 pi. Yeah? Okay, so what we're going to do is we're going to find that. Remember that when we wrote out what the radians were as decimals, it was 1.57 because that's half of 3.14, and then 4.71 because you add the 1.57 all the way to 6.28. Okay, and if you're thinking of, oh, what's my interval going to be? This would be 0 to 6.28. Okay, so you include the 0, you don't have to include the 2 pi or the 6.28. Okay, so you can estimate where 1.37 is. It is in quadrant 1. Okay, so if you estimate your 1.37, we know the corresponding place for the tangent is going to be across the unit circle. So to find that, I just have to take the given angle, the 1.37, and what can I add to that? Pi. And we are going to use the pi button, not just the 3.14. Okay, and so you can actually just take that answer and do plus pi to get 4.51. Okay, and then is that in our interval? Yes. Okay, if you were to add pi again, okay, that would be more than 6.28, then you wouldn't have to include that in your solutions. Now, when you are writing your equation for tangent, it's a little bit different. Okay, so we're going to write the simplest form of the equation, which means we don't want to do anything that's redundant or repeats itself. So the one period for tangent is pi. All you have to write for the all solutions is 1.37 plus pi k. So you don't need to write both of them out because if you do plus pi k, isn't that how we found this one? Plus pi. So it's going to hit that point. And then plus pi, plus pi, plus pi. Okay, so you don't need to because that would just be redundant for this one. Okay, so with tangent, you can always use that plus pi k because that is the period. All right, you guys ready for the next page? All right, so we are going to find all solutions. Okay, then we are going to list 6 specific solutions, which I would not want to say 5 times fast. 6 specific solutions. Okay, including at least 2 that are positive and at least 2 that are negative. Okay, so I'm going to help you with that part. So based on what we did for our last example, can you guys start part A? And in terms of the work that you need to show, for one that's a decimal, I do want you to show this step so that you're taking the inverse and what that is going to be. And then, Elliot, when you got that, will you tell me what you got for the inverse? 1.29. Nice. 1.29 is what you guys should have got. Okay, so that is going to be one of the places. So we already talked a little bit about the cosine in part A. How many places did you have the value for cosine? 2, which means there's another one that we have to find. And the way that we can find that is using our knowledge of where the cosine is positive on the unit circle. So the reason why we want to find where cosine is positive is because it says the cosine of theta is 0.28. Okay, that's a positive value. Okay, so if it's positive, you need to ask yourself, where is the cosine positive? Okay, so we know that the cosine is positive in what quadrants? 1, 4. Yes. Okay, so the cosine is positive in quadrant 1 and in quadrant 4. So 1.29, that's the value in what quadrant? In 1. Do you guys know why they, well, I'll tell you this. When it's cosine and it's positive, they're always going to give you the one in quadrant 1 and not the one in quadrant 4. Do you guys think you can tell me why? They will always give you the one that is in quadrant 1. You will always have to find the one in quadrant 4. Goes back to when we studied inverses. Remember when we studied inverses and we looked at those graphs? We had to restrict the domains. You guys remember what the domain is for the cosine inverse? 0 to pi, right? So quadrant 1 falls from 0 to pi. Is quadrant 4? No. So that means if you're doing sine, they're always going to give you an answer that's in 1 or 4, because that's negative pi over 2 to pi over 2. Same thing with tangent. Okay, so with cosine, they're always going to give you something that's in 1 or 2, because that's the definition of the inverse function. Okay, so it's up to you to find the other one. So we are on the case, 1.29. And it doesn't matter to me where you do your estimate. Okay, just as long as you have it in the right quadrant. So if you have the 1.29, okay, then you have to find where it is in quadrant 4. So let's look at some of our other values in quadrant 1. So if you have, for the cosine or the sine, root 3 over 2, 1/2, the root 3 over 2, root 3 over 2. Can you guys see that these are reflections of each other over the x-axis? Okay, same thing happens with all of those cosine values. So the same thing is going to happen with this cosine value. So the reflection would be here. Okay, how can we find the name of that angle? Okay, so yeah, so one way is, you can think of it like this, right? You're trying to find what that angle is. So if you're trying to find this angle here, you can take the 2 pi and you can minus the 1.29 because this distance is also 1.29. It's a reflection. Okay, the 1.29 measures the distance in radians. So when you're doing that, let's do 2 pi. Use your pi button, and then we will round. Was there another way you guys were thinking of doing it? Isn't this just also negative 1.29? If you want to call it by the negative name, you could. Okay? So that will work with cosine. Okay, so when you are writing all of your solutions, you need an equation. So 1.29 plus, and then the period for cosine is 2 pi, so it's 2 pi k. And then 4.99 plus 2 pi k. And then we'll just put a little arrow and we'll say, or you want to write that as negative 1.29 plus 2 pi k, that is fine. Okay, that will always work with a positive cosine, and you guys might like that better. Okay, so you have the choice for that. All right, and then once you have that, why don't you go ahead and start part B. Okay, so then Solomon, we told you that when you did the inverse. That is correct. So the inverse sine of 0.28 is 0.28. Okay, so that is your theta value. So that is going to be one of your solutions. Oh, also we are going to do the specific solutions as well. Let's finish this one and then we'll go back and do the specific. Does that sound good? Okay. All right, so the first part, we're going to talk this through in a similar way that we did this one. Okay, so it says the sine of theta is equal to a positive number. If the sine of theta is equal to a positive number, you just have to think about where the sign is positive in quadrant 1 and also what? 2. Okay, so what that means is you found the answer that was in quadrant 1. You have to find the other answer in quadrant 2. And the reason why is because, like we see on the unit circle, if you look at your y coordinates, okay, we can see that in quadrant 1 and quadrant 2, like pi over 3 and 2 pi over 3, those have the same y values. Okay, so we found the one in quadrant 1, now we have to find the one in quadrant 2. So we had 0.28 So it's always going to be some type of reflection. Okay, you can think of this distance as 0.28, and then you have to find the name of that angle. That angle starts at 0 and then goes to this line. Okay, how are you guys going to find what the name of that angle is? Yep, subtract 0.28 from pi. Because you know that the whole top half is pi. This little portion here is 0.28. So if we just do pi minus 0.28, okay, that's going to give us our second value. Okay, so we're going to write all solutions, and then we're going to go back for both of these and do our specific solutions. Okay, so we have 0.28 plus 2 pi k. We have 2.86 plus 2 pi k. Okay, when you are doing the specific solutions, all you need to do is use your equations to help you come up with the specific solutions. All right, so let's start with what we have here. So we have 1.29 plus 2 pi k. So 1.29, if I plugged in k is 0, that's a solution. Okay, you can also use the 4.99 right away. That is fine. Okay, and then if you do 1.29 plus 2 pi, that's going to give you another one. So 7.57, that would be a specific solution. You can just keep adding 2 pi if all you need are positive solutions, right? Okay, so those are places on the unit circle where you did a rotation would end up in a place where the cosine would be 0.28. Okay, now we do have to find some negatives. Well, one of them is the negative 1.29, so you could use that. Okay, if you took the 1.29, you could also minus 2 pi. Okay, that would give you negative 4.99. And again, you could keep subtracting if you needed another one. Okay, you could do 11.27. Okay, you could get some from the 4.99. You could do plus 2 pi there. You could do positive that. Okay, so there are an infinite amount of specific solutions. Are there any other ones that you guys found that we didn't write on the list that we should? Is that one that you got from the 1.25? All right, so based on that, do you guys think you can find 6 specific solutions for part B, including 2 that are negative and 2 that are positive? And I always start my list with the 2 given ones because I feel like those are just freebies. Okay, and then if you want a methodical way to do it, you can always just take the first one, add 2 pi, you get 6.56. You can take 0.28, you can minus 2 pi. This would be negative 6.00. You do want to round it because you need the 0.00 because it is a rounded answer. Then you can do the same thing for 2.86. You can just add 2 pi to that. And then you can subtract 2 pi to that. And I guess you could also just do this and put the minus in. Okay, what are some other solutions that you guys got? And so we get negative 12.29, 12.84, negative 18.57. All right. Now, for part C, this is not a decimal. Is this an exact value on the unit circle? Where the tangent is negative root 3 over 3? Yes. Okay, so we're going to use exact values here. Okay, so if it's an exact value on the unit circle, you are going to use an exact value. Okay, so on your unit circle here, the tangent is negative root 3 over 3. You can see the 2 places, right? Remember, for tangent, you only have to write how many places? For tangent, here, let's draw a visual. Okay, so it's going to be here, which you can call this point 2 things. You can call it negative pi over 6, or you can call it 11 pi over 6. So whichever one you want. Okay, this one is 5 pi over 6. So you can decide how you are going to write what the all solutions are. So your theta, if you use negative pi over 6, then all solutions is going to be negative pi over 6 plus pi k. You don't have to do 2 equations because they're directly across the circle from each other. Okay, so you only need 1 equation. So you can write your answer as negative pi over 6 plus pi k, or (11 pi over 6 plus pi k), or 5 pi over 6 plus pi k. Any of those are correct. You can use any of them. Okay, but you're only going to choose 1. Okay, that is the simplest form of the equation. Now when we find the specific solutions, we're going to have to use the exact values, and your exact values here can be found by adding pi. Okay, so again, I would just start with what you're given. Okay, the negative pi over 6. And if you do negative pi over 6 plus pi, that's like adding 6 pi over 6, right? So what's that going to give you? 5 pi over 6. So if you add pi to that, what do you get? See how these are all of our answers here? All of the equivalent answers. Okay, and then you could do that again if you want it. 17 pi over 6. You can keep doing that. Okay, you can also subtract pi. Again, start with the first one. Okay, so you could do negative pi over 6 minus pi. That would give you what? Yep. Okay, you could do that again. That would give you okay, so you can keep going, right? You can subtract again. Okay, negative 19 pi over 6. So I know that you can add those in your head, so that's okay. Just make sure you have your equation there. All right, and then for example 3, this says to find all solutions of the given equation, and then write the solutions in the simplest form. In terms of the solution, that means you want your equation in the simplest form. Okay, so no repeats in the equation if they are pi units apart. Okay, so I'll show you what we mean for that. So we have 2 cosine squared of theta minus 1. Okay, now if I were to give you 2x squared minus 1, you guys could tell me how to do that, right? What would we do first? What would we do first? Yeah, so how do we do that? What would be the first step to doing that? Add 1. Yes, why is only one person talking? Divide by 2. Okay, so you add 1, you divide by 2. Square root, and when you do the square root, what do we have to remember? Yeah, plus or minus. Yep, and then we are going to be rationalizing as well. Great. All right, so then I want you to do those few steps on part A. So when you take the square root, don't forget to do your plus or minus. That's going to change this a little bit. Okay, so you have 2 cosine squared of theta equals 1. And really, you can just jump to this stuff, right? 1/2. But I do want to see the square root, okay? Because sometimes the plus or minus is the part we forget. If you square root a fraction, you just square root the numerator. What's the square root of 1? 1, and then root 2, and then you have to rationalize. So then look at what you have. The cosine of theta equals plus or minus root 2 over 2. Okay, so because it's a plus or minus, you're going to have a special equation here. Think about where the cosine is root 2 over 2. In quadrant 1, where's the cosine root 2 over 2? Pi over 4. Okay, in quadrant 2, it would be? Yeah. I know, we can count. This would be 4 pi over 4, so this would be 5 pi over 4. 6 pi over 4, 7 pi over 4. Okay, so these solutions have the relationship where they are pi radians or 180 degrees from each other. So when that happens, okay, you are going to write your solution with 2 equations instead of 4. Okay, so technically, you could write that out with 4, but that wouldn't be the simplest form. Okay, we want it to be reduced. Okay, so your solution, and it says find all of them, so it's pi over 4 plus pi k. So the pi over 4 plus pi k, if you were to add pi to this, you would go to 5 pi over 4. And then if you add pi again, it's going to hit those 2 points. Okay, this one you could call 3 pi over 4 plus pi k. If you just said pi over 4 plus 2 pi k, it would only be this point.
No, pi over 2.
Oh, because of the quarters? For some reason, the textbook does not recognize that. Like, they only do it with the pi. Yeah, because that's something people have asked me before. But you do have the choice. You could say pi over 4 plus pi k, or you could say 5 pi over 4 plus pi k. That would be fine. You can say 3 pi over 4 plus pi k, or you can say 7 pi over 4 plus pi k, or you could even say negative pi over 4 plus pi k, because that one is the same thing, right? So you can use either name for that. Okay, so based on that, can you just try part B? So you can solve part B. Okay, so your first couple steps are the same, where you add 4 and then you take the square root. Okay, so once you get there, the secant squared of theta equals 4. Remember, I need you to show the square root. Okay, and then that's going to be plus or minus 2. Now keep in mind something that you could use with the secant. So you could find where on the unit circle is the secant positive 2 or negative 2, but don't we think it's going to be a little bit easier if we use the reciprocal? We're just more familiar with it, right? So what's the reciprocal of secant? Cosine. Okay, so if we use the reciprocal, the cosine would be plus or minus what? 1/2. And then that would be something that you can see on your unit circle. Okay, so I put that unit circle on the front of your note so that you can use that when you're doing your practice, okay? All right, so then your cosine, again, because it's plus or minus, you're going to end up having 4 places. Okay, if it happens at pi over 3, it's also going to happen at 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, they're all reflections of each other. Okay, so see if you can write out what your solution is going to be. Okay, so Anya, what's one of the equations you wrote for this? Yeah. All right, and then what would you write for your other equation? Say again. You did what? And then what was your first one? So whatever your two equations are, so you can use the 4 pi over 3 instead of the pi over 3. Okay, so this could be, instead of pi over 3, you could do the 4 pi over 3 plus pi k. Instead of the 5 pi over 3, you could do the 2 pi over 3 plus pi k. Okay, or if you wanted to use negative pi over 3 plus pi k, you could do that as well. Okay? All right, part C is a little bit different. What do we have to do for this one, you guys think? Factor. We are going to factor. Okay, and if it's a little bit easier for you, if you want to first factor when you have 2x squared plus x minus 1, if that's a little bit easier, we can do that first. Okay, so the way to get 2x squared is to have 2x and x. Okay, so what that means for this is we're going to have 2 times the cosine of theta and the cosine of theta. Okay, it has to multiply the negative 1, which means we need a positive and a negative, and we want the middle to be positive. Okay, so what has to go with the 2x, or the 2 cosine? Negative 1. So you have a negative cosine plus 2 cosines, that would make 1 cosine. Okay, and then from there, you're just going to set each one equal to 0. So you have 2 cosine of theta minus 1 equals 0. You have the cosine of theta plus 1 equals 0. And just like when we're factoring where we have, oh, it can be this or this, these are going to produce different solutions and they're all going to be part of our final answer. Now in this one, your cosine is equal to 1/2, but it's not plus or minus. So when that happens, you are going to do the plus 2 pi k. So you're going to find on your unit circle where the cosine is 1/2. We know one of them is at pi over 3. Remember, the cosine is positive in quadrant 1 and in what other quadrant? 4. And so you can call this 5 pi over 3, or some of you might just like using the negative pi over 3. Okay, so based on that, this part of your solution is going to be pi over 3 plus 2 pi k. And again, that's because you don't have anything across from it now. And then you can have negative pi over 3 plus 2 pi k, or 5 pi over 3, whichever one you want. And then for this one, you have the cosine of theta equal to negative 1. Where on the unit circle does the cosine equal negative 1? Pi. The point there would be negative 1, 0. Okay, and so you have pi, and will that be plus pi k, or will it be plus 2 pi k? 2 pi k. Because here, your point is 1, 0, right? They're not the same. So it's 2 pi k. The only time you're going to use pi k is if they are directly across the circle from each other. Okay, so just make sure all of your solutions are in radians and in simplest form. And then you're just going to leave them as exact values or your decimals as given. Okay, your assignment is 12 questions. I'm telling you that because when you look at it, you're like, oh, that seems like a lot. It's just 12 equations. And it is really important that you practice seeing those different types of equations